Hello, my name is Michelle Connolly, and last month I was invited by the Mount Willett Wilderness Forever group in Argenta, BC, and some people in New Denver, which is also in the West Kootenays, to speak about what ought to happen after fires burn primary forests, what we do and not do when we're thinking about other species and ecosystem health. They asked me to record the presentation for them, so that's what I'm doing. I was born north of Edmonton, and my family moved to Surrey when I was 10. In 2011, I moved to Prince George in Lheidli-T'enneh Territory to do my master's degree at UNBC, where I studied forest disturbance ecology. I run a volunteer group in Prince George called Conservation North, and I also have a day job as well. Our group is a collection of people who love nature, who love plants and animals, and want to make sure that they persist in our region and across the province. As many others have pointed out, we are in an era where most of the wildlife that we have enjoyed sharing space with for most of our lives are in big trouble. The total weight of Earth's wild mammals, so from elk, deer, mice, lynx, and orcas, is now less than 6% of the combined tonnage of women, men, children, and our farm animals and pets on Earth, and this concerns us. And the first main reason for this is habitat loss, which is showing as red here. Most of that habitat loss globally is forest degradation and deforestation. We know this already. So we're displacing wild animals and other life forms globally by turning natural habitats into roads, farms, urban areas, mines, and cut blocks. The world over, the biggest threat to biodiversity right now is not climate change, it's direct destruction of habitat. About 20 years ago, I was living in the Vancouver area, and a friend gave me a copy of this book called Virtual Clearcut, or The Way Things Are in My Hometown. It's about the socioeconomic decline of a forestry boom town, Prince George, and the clearcut it's referring to is the Bowron clearcut, which made Prince George infamous in the mid-1980s because it was so large that you could see it with the naked eye on satellite imagery at the time. It was 300 square kilometers in size. The Bowron clearcut was a, quote, salvage operation. So it was logged following a lot of spruce beetle mortality from an insect, the spruce beetle, which is a natural plant predator that occurs here, like the pine beetle. The idea that you need to log after a natural disturbance like a beetle outbreak or a fire is so pervasive that that message has ended up on a can of a popular local beer, which says that the Bowron Valley clearcut had to happen because of the spruce beetle. That's not the case, and I will explain why in this presentation when it comes to fire. I moved to Prince George about 15 years ago to continue my studies and get a credential. My research project was on forest recovery after an insect defoliation in the inland temperate rainforest that happened in the early 90s. So a defoliator is an insect that eats the needles and leaves off trees. So I put my maps together and decided where I was going to sample, and discovered during my first summer sampling that about half of the plots that I had planned on sampling had been logged, quote, salvage logged. I ended up finding enough unlogged plots to collect data, and that ended up being fine. That summer, the roads were really quiet, which I liked. There were very few logging trucks on Highway 16 and the Forest Service roads that I needed to get to my other plots. There wasn't any logging happening in the area. And the reason for this, I found out after a few weeks, was that the logging capacity was being deployed west and south of Prince George to salvage pine beetle forests. And this is what inspired my interest in this topic of post-disturbance logging and the processes in nature that seem to trigger it. When we're talking about post-fire logging, it's important to separate economic reasons for logging, which are totally legitimate, from ecological reasons. If we're going to be able to discuss this as a society, we need to be really clear why these decisions are made, what's motivating them. I think that these two things get muddled together a lot, and where I live, this is very common. Because I didn't come up with a lot of the information I'm about to present myself, I've put the sources on each slide, and I can provide anyone with information to follow up with afterwards. All my sources are peer-reviewed studies, except for one that's a BC government technical report. Whenever we're talking about any given forest, the first question that we always ask in our group is, has it been industrially logged in the past? That's because this matters when we're talking about what wildlife an area supports and other characteristics of a forest. I've zoomed into our Seeing Red map, and this is kind of centered on the Kootenays here. And you can do the same. It's an interactive map, and it works anywhere in BC. So red shows forests with a history of industrial logging, and green means that they've never been industrially logged. As we all know, the idea that you need to log right after a fire or other natural disturbance is very pervasive and is probably behind at least some of what's showing up as red on the Seeing Red map. The BC government has had a program for small-scale salvage for about 20 years, I believe, and it was tied to the pine beetle and meant to be available to small market loggers operating in small patches of dead and dying trees. But last spring, the BC government made it much easier for companies to log forests that have burned in wildfires and issued cutting permits for over 25,000 truckloads worth of forest, and most of that would have been primary forest, so forest that had never been logged before. The province is also signing wildfire salvage opportunity agreements with First Nations for volumes of up to 50,000 cubic meters, and that program was introduced 2 years ago. Tonight, I'm arguing that salvage logging natural forests is not compatible with protecting some of the things that we value in the long term. Most of BC's forests are shaped by wildfire. As a global change agent, fire has been around since the dawn of terrestrial plants some 400 million years ago. Because BC is very diverse topographically and geologically, with many climatic gradients, there is huge diversity in disturbance regimes and therefore natural communities. The wildfire regime of a place is determined by how often, intense, large, and seasonal fires are and how they vary. It's a way to talk about historical conditions in forests before European contact, which is very useful. Fire regimes can be driven top-down from the climate or bottom-up from the topography of a place, the plant community, and ignitions from indigenous fire stewardship or lightning. For example, the forests around Kamloops have a different fire regime than the ones around Fort St. John, which is different than the fire regime around Argenta. The main type of fire regime in Western North America is mixed severity fires that contain some low severity fires and some high severity fires. When we're talking about severity of a fire, it's about the mortality of overstory trees. So a high severity fire kills most of the dominant trees in an area. Because our forests in BC evolved with fire, much of our biodiversity did too. Biodiversity in plants and animals is related to having diversity of natural forest ages and structures. And those things emerge from the accumulation of natural disturbances of various kinds, intensities, and sizes on a landscape over time. Fire is essential for creating and maintaining habitat for animals and plants. All natural forests, including old growth forests, owe their structure and complexity to the workings of fire, as well as insects and disease. Basically, things that kill trees make wildlife habitat. This is true for every single natural forest you've ever set foot in. Death is a key process in nature. Pre-contact forests, forests that existed before Europeans showed up, were a mosaic, like in this image, with some having lots of old and some having higher proportions of naturally young forests, depending on where you are. Wildlife and other life forms plants, lichens, microbes evolved to fit the conditions of pre-contact unexploited forests. Fires leave behind biological legacies like standing and fallen, living and dead trees, thickets of understory vegetation that were left intact, other bits of surviving vegetation like seeds, rhizomes, and rootstocks. You get unburned patches of forests and stands of forest that burned at higher and lower intensities in every fire. That also means that you get different patterns of forest recovery across a landscape. The resulting complexity, both at the small scale, like in a stand of forest, and the large scale, like a landscape, support plants and animals and biodiversity. In natural ecosystems, things are organized and connected in strange and interesting ways. They're full of relationships that we do not see. Some people say that natural ecosystems have hidden wiring, like I'm trying to show in the little image on the top left. Underground fungal networks and their connections with trees are an example of this. Sometimes those connections happen on a way larger scale. For example, the number of salmon harvested in the Alaskan Gyre can affect rates of tree growth in the Upper Fraser River, for example. We know that removing wolves from an ecosystem can change how much willow is available for beavers, and therefore how protected a watershed is from severe flooding. Cutting a connection in one place will cause unexpected things to stop working somewhere else. And it's for this reason that scientists have long advocated precaution when we're managing complex ecosystems. You may have heard the term, the whole is greater than the sum of its parts. In nature, this is true. Natural forests are complex systems, meaning that their attributes are never very predictable, based merely on knowledge of their individual parts. Complex systems like primary forests are made up of many parts: trees, small mammals, birds, insects, soils, etc., and processes like death and decay, succession, disturbance cycles like fire and beetles, nutrient cycling from animals eating and pooping, migration, etc., that interact with one another and their environment over multiple scales of time and space. These interactions give rise to the variety of forest structures that we see in natural forests. And forest ecosystems have memory, which means that biological legacies of previous states influence present and future states. And the idea that ecosystems have memory came from Campbell, a report by Campbell. So when we're looking at a complex system like a natural forest, we need to recognize not only diversity in terms of species and structure, but also diversity of processes acting within the ecosystem. Seeing a forest as a food web is a useful way of understanding the movement of energy and matter, the role that a tree, a blueberry bush, a salamander, or a mule deer plays in the functioning of the ecosystem. In complex systems like primary forests, you get something called emergent properties, which are features in nature that are unexpected and arise from the collaborative functioning of a system, but do not belong to any one part of that system. An emergent property is something that a system has, but individual members of that system don't have. You get unique things arising only when the parts interact as a wider whole. And this is an example of that. It's called a murmuration. Another example is an ant colony. There are lots of things an individual ant cannot accomplish by herself, but when she's part of a colony, you get this organized group that can explore its surroundings, protect the queen, find and bring back food. That ant might only live for a few months, but the colony survives for years. The emergent properties of natural ecosystems create patterns that humans are just beginning to understand. Complexity is a key component in resilient ecosystems. Ecological complexity is the idea that the complex interactions between living systems and their environment enable nature to resist stress, reorganize itself if necessary, and recover after disturbances. A big part of this complexity is the existence of dead trees. They create the conditions for biodiversity. And fire, insects, and disease are complexifying agents. So over time, they make forests more diverse, thereby making it possible for species to coexist. Our wildlife have evolved since the Ice Age left 100 centuries ago to take full advantage of and participate in the movement of energy through ecosystems. A food web, so who eats what, who lives where, and who makes a home for whom, is an energy pathway. Natural ecosystems and the biodiversity that underpins them are the product of forests becoming more complex over time. Unbroken rhythms of tree death and rebirth, soil accumulation, and the movement of energy between plants and animals and back again. So what is so-called salvage logging? It's the removal of dead trees or trees damaged or dying because of injurious agents to recover economic value that would otherwise be lost. That's the definition from the Society of American Foresters from 1998, and that's actually a very honest definition. The most obvious thing salvage logging does is remove the key structures of a forest. It takes the living and dead, the standing and fallen trees, the biological legacies, the ecosystem's memory. Removing the big old trees means that there will be prolonged periods of time before you will get structures like that again. When you remove these trees, this precludes them getting to the forest floor or to streams. People have speculated that this takes many centuries to get back because you need the tree to have a whole lifetime and then die before they have value for wildlife. The depletion of biological legacies is a problem for the wildlife that are dependent on them, for example, many birds. Salvage logging removes the pulse of big dead trees and logs that would normally go into aquatic environments where they provide habitat and maintain stream health, for example. And I'll talk about this a bit more. Salvage logging affects soils. Fires often burn the top organic component of soils. A fire may consume the litter and duff if it was a hot fire and expose the mineral soil underneath it. This may make soils more vulnerable to compaction and erosion by ground-based logging equipment like skidders. Burned forests often contain piles of fallen trees where removing the wood is more challenging and requires more skidding, which really disturbs the soil. Research has shown a direct relationship between mechanical disturbance to the post-fire environment and accelerated erosion. Compaction means decreased infiltration of water when it rains, increased overland flow, and accelerated sedimentation, which then affects aquatic systems by reducing the survival of fish and other species. So salvage logging will modify the hydrology of a place, making floods and slides more likely. Soil compaction can persist for up to 80 years in many forest soils and even longer in areas with high clay content. And this is a lot longer than the influence on soils that are associated with fire. Accelerated surface erosion also leads to long-term reductions in soil productivity, or the ability to grow plants, basically. Because soils and soil productivity are irreplaceable in human timescales, soils take about a century per centimeter to develop. The fact that salvage logging that compacts soils reduces nutrients and accelerates erosion is very concerning. The recovery of organic matter in soils, which is essential to the recovery of soil productivity in areas with high and moderate severity burns, can be accomplished efficiently and inexpensively by simply leaving burned areas undisturbed. In a study from the Eastern Boreal Forest, where they get stand replacing fires, They looked at forests with jack pine, black spruce, and aspen and found that there were better seed beds for spruce and pine seeds in salvaged areas because the skid trails had exposed the mineral soil. But there were fewer germinants or baby trees becoming young trees because they were killed by machinery traffic. So there really was no advantage to the salvage logging for tree regrowth. So aspen came to dominate those salvage areas, and they did fine because of the way they reproduce by their roots instead of with seeds. There also might be harmful effects from salvage logging on soil microbe habitats, which are important for recovery after a fire, and the pioneer plants. The plants that establish early after a fire, so the pioneer plants, influence the dynamics of that forest for decades at least, and they do so by fixing nitrogen, which is a limiting nutrient, and making it available to other plants by hosting mycorrhizae or fungal networks that help trees share nutrients. They also do it through pollination and seed dispersal, by providing habitat for wildlife, and by protecting soils from erosion. So salvage logging affects what's growing back. Seedlings that germinate after a fire might be mechanically damaged or killed by a machine when an area is logged right after a fire. Researchers have shown that even where salvage logging occurred in winter on top of a half meter of snow, logged areas had significantly lower understory plant biomass, fewer species of plants, and lower growth and survival of both tree and shrub species than places that were not salvage logged. Aspen, which you'll often see popping up right after a fire, are associated with the accumulation of nitrogen, which is an essential nutrient for plants. And we don't actually know the mechanism behind it. It might be about leaves, about the leaves from aspen keeping the soil pH ideal for microbial activity. But a study from Alberta found that fire salvaged areas had 60% fewer aspen suckers, so less vegetative reproduction than burned forests that were left alone, and that those suckers in the salvaged areas were also smaller and had lower leaf area. Other nitrogen-fixing pioneer species like alder and lupins can be damaged, which would alter pathways of nutrient replenishment in any post-fire forest. And other studies of post-fire logging after high-severity fire show that it has led to the depletion of soil calcium, magnesium, and phosphorus, such that levels of these nutrients would not return to pre-fire levels within the planned rotation time of 110 years. So that's a very clear long-term effect of salvage logging. Everyone here would know that many wildlife require dead trees, whether they're standing or fallen, snags or deadwood. All the species that use snags, as well as fire specialists, don't benefit from salvage because obviously it limits tree cavity formation and availability. Woodpeckers, flying squirrels, pine martens, nuthatches, the list goes on, they would not find homes here. In Canada, burned forests support a distinct species groups of songbirds relative to unburned forests, and salvage logging has been found to alter those bird communities. Canopy and cavity nesters and birds that eat insects were the least likely to be detected in the salvaged areas, according to one study. There is research showing boreal songbird declines from salvage logging in the boreal forest and declines in fire-associated birds in Scandinavia after salvage logging. The birds listed here are some species that were in burned mixedwood boreal forest, but not in salvage logged ones. On the right is a black-backed woodpecker. They thrive right after fire and are found in high densities in forests that have been recently burned, probably to capitalize on the availability of juicy wood-boring beetle larvae that feed beneath the outer bark of trees. I watched another species of woodpecker pull a huge larva out of a burned spruce tree in August near Vanderhoof. These are two types of wood-boring beetles that are attracted in large numbers to burned forests. Wood borer beetles help decompose snags and downed logs, and they also pollinate plants. The nutritional benefits of wildfire for moose, elk, and deer are also well documented. Burned forests provide higher quality forage than unburned areas, and ungulates using these habitats tend to survive and reproduce at higher rates. A study of the Shovel Lake wildfire near Prince George is showing that salvage logging after the burn is resulting in lower quality forage for moose and deer. And this is important, of course, in part because food security is a very important matter here and in other parts of the province. Most types of logging require roads because you need to move the wood away somehow. Salvage logging often requires new road networks into places that didn't have roads before. And of course, roads bring invasive plants, people who poach wildlife, and more wildfire risks associated with people. The construction and reconstruction of roads and landings is not consistent with post-fire ecosystem recovery, according to this researcher. You don't have to read this slide. It's from the table from a book that was released this year and shows a list of studies from around the world on the effects of salvage logging on forests. And it's from this book on the left, which came out, the second edition came out just this year. The second book on the right is about 15 years old, and it is a very good book when it comes to better understanding the impacts of logging after natural disturbances. We know that old growth forest is now rare in BC. Well, so are natural young forests, like recently burned ones, like this fellow is standing in near Fort Nelson. A retired UNBC researcher who looked at 5 million hectares of forest in central BC, where I live, found that only 1% of that originated from unsalvaged fires that occurred less than 60 years ago, which is far less than you might expect given the fire regime here. Dr. Karen Price has also talked about the rarity of natural young forests in BC because of salvage logging. Natural young forests are not as charismatic as old growth, but they're just as important. So you'll see language in BC government, federal government, Forest Enhancement Society, and Forestry for the Future literature and press releases that suggest that wildfire damages, destroys the land, and that people can repair, rehabilitate, or restore it, usually by salvage logging at first. The term resilience is often used now to justify industrially logging burned forests. However, as we're learning, these activities cause additional damage and prevent reestablishment of native species, ecosystem processes, or plant succession. This researcher, who's quoted on the upper right, said that a crucial priority of post-fire management is enhancing the capacity of burned areas to recover naturally. This press release from the BC government this spring says that salvaging wildfire damaged timber will help restore areas for wildlife. No, it does not. That's not true. Climate change is happening. We're in a new climate fire era where fire is increasingly governed by the cumulative emissions we've put into the atmosphere from both the unprecedented burning of fossil fuels and logging, by the way, which is Canada's third highest emitter. A lot of recent fire activity in Western North America is being driven by temperature, but all aspects of weather, rain and snow, or lack of it, relative humidity and wind influence moisture in forests and therefore their flammability through their interactions, of course, with the topography and plants. With all else being equal, more hot, dry, and windy days will invariably lead to more ignitions, faster spreading, longer burning, and ultimately larger wildfires. So what do we do? This is what these researchers said. One of the main ways we can promote ecosystem resilience is through maintaining the inherent complexity of ecosystems and therefore ecosystem response diversity to environmental change, so that ecosystem vulnerability to any single future disturbance event is low and the potential to reorganize following disturbance remains high. In my opinion, there is no real way for humans to engineer this resilience. It has to come from nature, which has self-managed for millennia. And I think we can very easily do much more harm by tinkering with these systems like we've been doing. These researchers say that when it comes to facing down climate change, large areas of primary forest, that is forest that's never been logged, are expected to have higher adaptive capacity and stability compared to forests under human pressure because of their connectivity, biodiversity, and microclimatic buffering. What that means is, when you talk buffering, that is, when you think of a really hot day, you walk into a natural forest and it's much cooler. Forests modify the impacts of climate by conserving water, making shade, and protecting plants and animals from drought stress and extreme temperatures, both hot and cold. They absorb heat during the day and release it slowly at night, thereby evening out the extremes. How do we support ecological resilience in the context of habitat loss and climate change? We safeguard the adaptive capacity present in natural or primary forests by leaving them alone. This is from a BC government report that I read when I was preparing for the event I spoke at. These guys explain that in BC and globally, the last 50 years have seen substantial changes in societal views about how forests should be managed. They say that public opinion has shifted from supporting sustained yield to sustainable forestry, and finally to what they call ecosystem management. I would say, though, that this is no longer the case. Ecosystem-based management is about logging primary forests better, and many groups do not want this, and I will explain why. I want to talk about why Conservation North advocates for the protection of all primary forests, not just old growth. It has to do with everything you've just heard me talk about. When you look at what the government inventory data say about the age of any given forest, what it shows is the age of the dominant trees, the oldest living trees. That's it. A younger natural forest, like this one, which is in the rainforest, that shows up in the government inventory as being 100 years old, say there was a severe fire that killed most of the trees 100 years ago, it will contain standing dead trees, hollows, rotting logs, all of which are 2 to 3 times the age of those dominant living trees. It takes several generations of the oldest trees dying to create a load of fallen, rotting logs on the forest floor, like what's in the photo here. This log represents unbroken natural forest development over maybe 500 years and is a very important habitat feature because it's used by voles and mice, which are the base of the terrestrial food chain, and probably a long-toed salamander at least, and many insects and other invertebrates. So a natural forest like this one, that's 100 years old on paper, looks quite different than what a plantation will look like in 100 years. If we just look at the BC government's forest inventory and see that a plantation is now 100, we assume that it looks like a natural forest of the same age, like this one, but that's not the case because it's just the dominant living trees in that plantation that are 100. It will take several more generations of tree death and decay in that plantation over time to get the important structures wildlife need back, the standing dead trees and the fallen rotting logs in particular. The wildlife here do not have this time. And the BC government has no intention of letting plantations grow to maturity to recruit the habitats that were lost. I don't have a photo of a 100-year-old plantation because the oldest ones we have are not that old yet. If you're talking about forests regenerating after logging, It's not simply a matter of just waiting 100 years for the trees to grow. You need to wait long enough for enough of them to rot and fall over before it will look like and function more like a natural forest again. So we're underestimating by a factor of 2 or 3 the time it takes to get back attributes that primary forests have, like rotting logs, which of course get crushed by machines when you log, or they get burned in a slash pile. A 100-year-old natural forest that regenerated after a fire could be considered, therefore, to be 200 or 300 years old from the perspective of wildlife. So these forests are therefore a non-renewable resource. Natural forests are a lot like a pot of boiling water. So if we imagine that this pot represents primary or never logged forest, and the bubbles represent old age classes or old growth, at any one given time, 30 or 50 or 70% could be bubbles, depending on the forest type where you are. So it would be different if you were in the West Kootenays, or in the Okanagan, or the Great Bear Rainforest, or way up in the Boreal. Every ecosystem will have a different proportion of bubbles, and natural forests are always changing. Some of these forests will be old, some will be mature forests on the cusp of being old, some will have had a recent fire where seedlings are shoulder to shoulder with newly created wildlife trees. My point here is that the bubbles of old growth require that the entire pot of primary forest be left to its own designs. Any type of rotational forestry stops this process in its tracks. And the result is permanent habitat loss, followed by the collapse of food webs and the loss of biodiversity. But this got us thinking. Industrial forestry has been doing its thing here for decades, targeting old growth forests for the most part. So if we're also taking the natural forests that are not considered old, for example, recently burned natural forests, then we're not only getting rid of what's old right now, we're also getting rid of what's going to become natural old growth one day. So where is the future naturally regenerated old growth going to come from? The answer is nowhere. The future of a regime that annihilates both old growth and younger natural forests is a future of human-made forests, which are inferior to natural forests for wildlife for a really long time, like centuries or longer. When a natural disturbance, like a fire or a beetle outbreak, is severe, so it kills most of the dominant trees, BC's Forest Inventory database will record that age as being young again, because the administrative age of that forest is based on those dominant trees. So it's no longer technically old growth. The age on paper of that forest gets administratively reset after a severe insect outbreak or a severe fire goes through. Does this mean that that forest no longer has ecological value? Of course not. Some of you might remember that in 2021, the BC government published this report, which was prepared by 2 professional foresters hired to canvass the public and determine what people wanted when it came to old growth forests. One important thing that came out of this process was a commitment to what they called a changing paradigm towards biodiversity and ecosystem health. On the BC government website, they state that they are committed to protecting and conserving biodiversity and ecosystem health, and they released a framework document a year ago in November 2023. And when I read it, it blames fire, among other natural and climate change related events, for declines in biodiversity, instead of the actual culprits, which for one are the cumulative impacts of roads and cut blocks over the last 60 years. This is worrying because if you can't acknowledge what has caused a problem, it's unlikely that you're actually going to solve it. On top of that, it was painfully obvious that the ecological importance of natural disturbances was totally lost on the authors. They proposed a zonation system with a protection zone that would allow logging in it. And this is just an excerpt from this report. There may be some management of activities to maintain ecosystem health and manage risk from insects, fire, and disease. They also said in another part that we have forests, this is another quote from this report, we have forests that are protected for ecosystem biodiversity reasons, but are promoting landscape ecosystem health problems because of our no-touch policy. That is pure bullshit. It's pure forestry bullshit. The idea that somehow we need to manage forests when these natural events occur, or else really bad things will happen. So we thought about our region and what this all means, and we came up with an alternative zonation system that actually responds to the needs of nature. In that old growth report that I just mentioned, the zonation system they proposed was pretty terrible. So we came up with something different. Because there are fundamental trade-offs between industrial forestry and biodiversity, we can't do everything on the same piece of land, which is the mentality and the practice of forestry, the idea that you can have these integrated uses on the same piece of land. We know that that's not working. There's plenty of proof of that. Industrial logging and protecting plant and animal habitat is incompatible on the same piece of land. So we need to separate incompatible uses and safeguard the adaptive capacity that's present in natural forests. To that end, we support a system of functional zonation. If we want healthy biodiversity in a changing climate, we need to allocate land to the maintenance of healthy ecosystems and the species that those ecosystems support. We think that primary forests ought to be zoned out of any kind of industrial management. That restoration should focus on degraded areas that can connect patches of primary forest, and that a third zone for forestry ought to be where management can take place. That's where management for forest products, for example, should be. Life needs a mosaic of primary forest. If we want these animals and plants in the world, they need their own space. This is who we need to plan for. This is not our idea of biodiversity and ecosystem health. What wildlife need, what biodiversity requires, is what they always had before contact and the advent of industrial forestry. So this researcher says, based on our current understanding of forest recovery following disturbances, timber salvage is most appropriately viewed as a tax on ecological recovery. And this other researcher says, salvage harvesting will undermine many of the benefits of major natural disturbances. We need to lifeboat biodiversity through this extinction tunnel that we're in. And we can't do that if we're chipping away at what's still natural, the primary forest showing on this map in green here. What's in green on this map will continue to have fires and insect outbreaks. And when that happens, the best course of action is to leave them alone. Thank you for your attention, and you can contact us anytime at info@conservationnorth.org.